inducing a realm that encompasses a universe, galaxies, stars, and planets. The universe. The universe comprises of all space, time, matter, and energy. It is estimated to be around 13.8 billion years old and is continuously expanding after Big Bang. It contains various structures like galaxies, stars, superclusters, clusters, and approx 90% of universe is dark matter and dark energy, which is remain mysterious. Galaxies. There are three main types of galaxies: spiral, elliptical, and irregular. The our galaxy is also known as Milky Way galaxy, and it is spiral galaxy. Galaxies can collide and merge with each other, leading to new star formation and destruction of old ones. Understanding stars. Stars are formed out of dust and gas in space, known as nebula. Under gravity, these materials collapse and heat up, igniting nuclear fission. Stars have distinct life cycles, ranging from red giants to supernovas, depending on their mass. Stars can be classified into different categories like their temperature, size, and brightness, including red dwarf and blue giants. Our solar system. Our solar system includes a sun and its 8 planets. Our sun is a medium-sized star providing light to all planets and is 99.86% of our total solar system mass. Our planets follow and orbit, resulting in seasons and climate. Our neighboring planets. Mercury is the closest planet to Sun and has extreme temperature variation and rocky surface. Venus is similar in size to Earth but has thick and toxic atmosphere filled with carbon dioxide. Mars. Mars, known as a red planet, and has a polar ice caps and thin atmosphere. The outer planets. The largest planet in our solar system, Jupiter, is a gas giant with strong magnetic field and dozens of moons. Saturn. It is famous for its rings and has rise and rock particles. Uranus and Neptune. Uranus and Neptune are ice giants of our solar system and have a sideways rotation. Dwarf planets. Dwarf planets are celestial bodies that orbit the sun and not large enough to classify into planets, like Pluto, Eris, Make. Conclusion. Thus, exploring space helps us understand fundamental questions about our universe, including its origin and possibility of life beyond Earth. By studying space, we can appreciate our planet's uniqueness and interconnection of celestial phenomena. Advancement in technology and international collaboration pave the way for future exploration and manned mission to Mars and beyond. Thank you.
I am Shiv.
And I am Radha.
Today I am presenting on PPT on topic the human earth.
The human eye and the colorful world. Journey into vision, what we explore.
The eye design, how we see, focus and absence. Defects and corrections, the colorful world.
The marvel of the human eye, the most important sense organ for seeing the colors world. Our eyes are truly engineering marvel capable of capturing and processing a dynamic range of lights and colors, much like the most advanced cameras. Key parts of the eyes and their function.
Cornea, eyes and pupils, lens, retina, optical nerves.
Closer look of inside the eyes. How we see the vision of process.
Light enters, focus and inversions, signal generations, brain interpretations.
Key points taken.
The eye is dynamic optical system, accommodation in surface, Third, brain complete the pictures.
Power of accommodation, focusing near and far.
The brain role in visions. The brain does not just receive signals, it accurately constructs our visual realities.
It corrects the inverted image from the retina, process color, shape and movement and generates them into a choice process.
Thank you.
Delightful morning, everyone. I am Kanan,
And I am Bushra.
and today we are here to present our topic, the circulatory system.
The human circulatory system, also known as cardiovascular system, is a network of blood vessels and organs that circulate throughout the body. The distribution of food, oxygen to all the parts of the body as well as removal of waste is performed by a transport system. The human circulatory system mainly consists of three parts: the heart, blood vessels such as arteries, veins and capillaries, and the blood, the circulatory medium.
Our next topic, the heart. The heart is the pumping organ of our body, propelling blood throughout the circulatory system. The heart has four chambers: the right atrium, left atrium, right ventricle, and left ventricle. The right atrium receives the deoxygenated blood from the body via vena cava. It is then passed to right ventricle, which pumps it back to lungs for oxygenation. The oxygenated blood reaches right atrium, which then moves to left ventricle, which pumps it to the body.
Our next slide is the blood. Blood is a connective tissue which mainly consists of two parts: plasma, the fluid part, and the cellular elements, the solid part. The cellular elements is of three types, which is red blood cells or erythrocytes and white blood cells, leukocytes. Red blood cells carry oxygen which from hemoglobin, which is present in it, to all the parts of the body. Now, white blood cells. White blood cells protect us from the diseases that enters along the food. And now, platelets. Platelets is a fluid part which consists of water 90 to 92%, inorganic salt 1 to 2%, and organic salt 7 to 8%. They gather at the site of injury and help the clotting process. Now, plasma. Plasma is a straw-colored liquid where the components float in the blood.
Our next topic is the blood vessels. We have three types of blood vessels. Number one, arteries. Arteries are supplied with thick walls to handle the blood pressure. Next we have veins. Veins have walls in them to prevent the backflow of the blood. Next up we have capillaries. These are microcellular vessels which helps in exchange of oxygen, gases and nutrients.
Now, double circulation. Since the circulation of blood throughout the heart is twice, this circulation of blood in the heart is known as double circulation. The circulation of blood between the body organs and the heart, except lungs, is known as systematic circulation, whereas the circulation between the lungs and heart is known as pulmonary circulation. Thank you.
Now, I would like to conclude by saying a healthy circulatory system leads to a healthy life. Thank you.
Delightful morning everyone. Today, me and my friend Vyang are going to demonstrate our presentation on human digestive system. Here are the contents. The human digestive system is a complex network responsible for breaking down of food, absorbing nutrients and expelling waste. Our first topic is overview of human digestive system. The digestive system comprises several organs including the mouth, esophagus, stomach, small intestine and large intestine. Key organs such as the liver, pancreas and gallbladder support digestion by producing digestive juices and enzymes and bile. The small intestine is vital for nutrient absorption as its lining is covered with villi and microvilli and that increases the surface area.
Now we will learn about the digestive processes. Mechanical digestion begins in the mouth as food is chewed, while chemical digestion starts with enzyme in saliva. Enzymes plays a crucial role in digestion by catalyzing the breakdown of complex food molecules in the stomach. Pepsin begins protein digestion while pancreatic enzymes like amylase and lipase act in the small intestine to digest carbohydrates and fats. The digestive processes is regulated by the nervous system and hormones. Now, the conclusion. Understanding the digestive system's complexity highlights its vital role in maintaining overall health. From breaking down food to nutrient absorption, each part of the system must function efficiently.
Delightful morning to one and all present here. Today, me and my friend will tell you about on the ability of plant reproduction.
Plant reproduction is of two types such as asexual reproduction and sexual reproduction.
In asexual reproduction, only single parent is involved, but in sexual reproduction, there was two parents involved.
What is reproduction? Reproduction is a process by which living organisms reproduce within the of the same species. Reproduction is necessary for the survival and increase in populations. If organisms do not reproduce, their population decreases and species live extinct.
So now there was many types of asexual reproduction. Like there was two types of fission, binary fission and multiple fission. In binary fission, only a single individual break down into only two individuals. But in multiple fission, only a single parent break down into many individuals.
Also, there is type of other asexual such as fragmentation, diffusion, multiple fission, and spore formation and hyper.
Now there was regeneration. In this method, the body was regenerated. Like in planaria, the body was regenerated when it was cut down or break down.
Like in flower, the reproductive part of flowers are such as stamen, pistil, anther, and stigma. These when the body grain is and grow and then the ovary it reproduces into offspring of life.
Now next was pollination. There was two types of pollination, self-pollination and cross-pollination. When the pollen grains transfer in the same flower, then there was a self-pollination, and when there was in different flower, then there was a cross-pollination.
In fertilization, after the pollen grain is in the ovary, the zygote is formed and it is covered by the leaves so that a new flower is formed.
Good morning to everyone. My name is Dushav Singh.
My name is Arvind Singh.
Today we are going to introduce to the electricity. What is electricity? Electricity is the flow of electric charge, usually electrons through a conductor creating current. This current powers devices and systems, making it a fundamental form of energy. Now, there is potential difference. The potential difference is the between the 2 points of in an electricity current defined as the movement of the work done in the movement of a unit of charge from one point to the another point. Here, this is the Ohm's law. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it, provided our physical conditions and the pressure remaining constant. Mathematically, this current voltage relation can be written as the equation. The constant of proportionality R is resistance and has units of ohms with symbol of ohm. Now, electricity power. The electricity power is the rate of which the work is done in the energy transforming into an electrical current. Simply putting it is the measure of how much the energy is used in the span of the time. Combination of resistors in series combination.
For n number of resistors connected in series, the equivalent resistance R equal is equal to R1 plus R2 plus R3 is equal to plus Rn. The total resistance of the current is determined by adding the resistance of each individual resistance.
Now, combination of resistance in parallel connection. From a number of resistance in the parallel, 1 by R is equal to 1 by R1 plus 1 by R2 plus another R3 is equal to what you answer. The total resistance of current is determined by adding in the of the resistance of the which each individual resistance.
Advantages of fuses. Fuses are inexpensive, simple, automatic, and they protect the circuits from overcurrent and they require no maintenance. They are faster than circuit breakers and offers current effects under the short circuit conditions.
Thank you.
The light from volume 1 and all present here. Today I will clear the nothing is here to present a PowerPoint presentation on basis of nutrition in plants. So let's start with new topic, why plants are vital for us.
Why nutrition is vital for plants? Plants are foundation of nearly all ecosystems, producing their own food through photosynthesis. However, this process relies heavily on the availability of specific nutrients absorbed from the environment. It helps in growth and reproduction. Nutrition serves as building blocks for plant cell tissues and organs, enabling growth and the production of seeds and fruits. It helps in energy production. They facilitate metabolic processes, converting absorbed energy into usable forms of various plant hormones. It helps in disease resistance. A well-nourished plant develops a stronger immune system, making it more resistant to pests, diseases, and environment stresses.
Now it's time to the building block of the plant, the 17 essential elements.
The foundation of life, just like us, plants need a balanced diet to thrive. Understanding plants. Nutrition is the key to cultivating a greenery, healthier world.
Beyond photosynthesis, the sunlight is important for plants to make the food. This presentation relies into chemical energy is converted into sunlight energy. Our journey today, we will cover why nutrition is used for plants, as they also make food for themselves, as they also make food for ourselves.
Quantity versus cruciality. Macronutrients and micronutrients. Now, while all 17 essential elements are crucial for plant health, they are required in vastly different quantities. These distinct categories then into macronutrients and micronutrients. Macronutrients needed in large amount of plant growth and development. They form the bulk of the plant nutrition intake.
Micronutrients needed in tiny amounts, but their absence can be just determined as the lack of energy. They are crucial for enzyme functions.
Its examples are nitrogen, phosphorus, potassium, calcium, magnesium, sulfur.
Its examples are iron, zinc, copper, boron, molybdenum, and chloride.
A balanced supply for both is paramount. As a deficiency in even one micronutrient can severely impair a plant's ability to utilize macronutrients effectively.
Now it's time for the big three and big. The role of nitrogen, phosphorus, and potassium and nitrogen, phosphorus, and potassium are three micronutrients. Often referred to as NPK, they are mostly frequently deficient nutrients in the soil and thus to maintain the health of the plant.
Now, nitrogen. Function. Essential for chlorophyll production, promoting lush leafy growth and vibrant green color. Deficiency. Yellow leaves, chlorosis, stunted growth.
Now it's time for the function of phosphorus. It helps in good maintaining of the plant, flowering, fruit, and energy transfer with the help of plant. Deficiency. Purple or reddish leaves, poor flowering, weak root system.
Now, potassium. Function. Regulate water movement, enhances disease resistance, and improve overall plant vigor and quality. Its deficiency, yellowing or brown leaf edges, weaken stems, increase susceptibility.
Understanding axial ratios in fertilizers allows for tailoring nutrition, addressing special plant needs for the healthy nutrients.
Cultivating a green future. Understanding plant nutrition is just an academic exercise. It's a fundamental aspect of sustainable agriculture, environment stewardship, and ensuring food security for our planet. By providing plants with the right balance of nutrition, we empower them to thrive, benefiting ecosystem and human life alike.
The main key takeaways for nutrition in plants are plants with 17 essential elements for healthy growth. They are categorized into macronutrients, large amounts, or micronutrients, trace amounts. Nitrogen, phosphorus, and potassium and NPK are vital for key functions like leaf growth, root development, and overall plant health.